Today, in this video, we are going to talk about angle between two lines. And the previous knowledge which we require is the angle between two vectors. Suppose I have two vectors, A vector and B vector. Angle between the two vectors is given by cos theta is equal to A dot B divided by modulus of A times modulus of B. That's the angle between two vectors. The angle between two vectors can be an acute angle, obtuse angle, it could be sometimes like that, right? The two angles, the vectors, two vectors could be that way. And so the angle between them can be an obtuse angle. So depending on which your A dot B will turn out to be positive or negative. If it is positive, that means your theta is going to be acute. And if A dot B ever happens to be negative, the angle between the two vectors is going to be obtuse. So that's the previous knowledge which we require. Now we are going to talk about the angle between two lines. So I'm going to draw two lines here. So I have a line L1 and another line L2. So I have L1 and L2, two given lines. And what we are looking for is the angle between the two lines. To find the angle between the two vectors, if I ask you to measure the angle between these two vectors, we have a normal tendency to measure the angle, the acute angle between the two and not really the obtuse angle. Maybe you would tell me that the angle between the two vectors is 60 degrees and not 120 degrees, unless otherwise you purposely want to tell me, okay, the angle between the two lines is 120. But conventionally, the angle between the two lines when we measure, we tend to measure the acute angle. So that's the expected answer, 60 degrees and not 120 degrees. Let's take a general case. So this is the angle theta I'm looking for. We know that every line has a direction vector on it. So L1 has a direction vector, we call that as B1, and L2 also has a direction vector, a parallel vector to it, which is B2 vector. Now if I want to find out the angle between the two lines, isn't that the same as the angle between the two direction vectors? So to find the angle between the two lines, practically what I will do is I'll find out the angle between the two direction vectors, B1 and B2. And we know how to find out the angle between two vectors. That's a formula. The only thing is my A vector becomes B1 and my B vector becomes B2. So I replace A and B by B1 and B2. So the angle between the two lines is given by the formula cos theta is equal to B1 dot B2 divided by modulus of B1 times modulus of B2. So that's the angle between the two vectors. But now we know that we look for the acute angle. And if you are looking for the acute angle, I don't want this B1 dot B2 to turn out to be negative. And if it turns out to be negative, when I do cos inverse of that, that's going to give me an obtuse angle. So I want to avoid that situation. So what I will do is take absolute value sign. And with the absolute value sign on, that's going to be always the acute angle. So that becomes the formula for angle between two lines. So what we are going to do now is we'll do the exercise questions. So we are on exercise 13C. This is exercise 13C question number 1. And they have given me two lines here. L1 is x is equal to negative 4 plus 12t and y is equal to 3 plus 5t. That's the first line. And then there is a second line. I'm going to write that as well. So the second line L2 is x is equal to 3s. Basically, I just want to put it like 0 plus 3s. Okay, that's 3s. Just to put it in the same format, which is not necessary. Y is equal to minus 6 minus 4s. So when you look at these two lines, I just want to know what is its direction vector. What is the direction vector for L1 and what's the direction vector for L2? So to make things clear, probably this particular format is called the parametric form of a line. We know that it's called the parametric form of a line. I want to put it in the vector form just to show you and not really necessary to pick up your B1 vector. So in the vector form, I say xy is equal to the A vector. The point vector is the first number there, minus 4, 3, that's my A vector, plus t times 12, 5. I just want to double check whether this is actually the same as that. So if I have a vector on the left side, I have a vector on the right side, and I try to equate the I coefficients, and when I do that, x is equal to minus 4 plus 12t, which is the first one, and when I equate the j coefficients, y is equal to 3 plus 5t. So that's the vector form of this line. And also the second line, if I write it, x in the same format, xy is equal to 0 and minus 6. See, that's the reason why I added 0 there, which was not really necessary. You could have otherwise also thought about it. This is s times 3 and minus 4. So this turns out to be my b1 vector, and this turns out to be my b2 vector. And the angle between the two vectors is given by this formula. Cos theta is equal to absolute value of b1 dot b2 divided by modulus of b1 into modulus of b2. Just simply put it into the formula. So I get cos theta is equal to absolute value of b1 12.5 dot 3 negative 4 divided by modulus of b1, modulus of a vector. If a vector is xi plus yj a vector, then modulus of a vector will be root of x square plus y square. So that's going to be root of modulus of b1 vector, root of 12 square plus 5 square into root of 3 square plus 4 square. Just work it out. 12, how do you find out the dot product? Multiply the I coefficients plus multiply the j coefficients. So 12 3s are 36 minus 20. It's anyway positive, so divided by, this is root of 169 into root of 25. So that gives me 16 by 65, 13 times 5. So theta is equal to cos inverse of 16 by 65. On a paper 1, you would leave it like that, and if it is paper 2, you put it in the calculator and get the angle in degrees. Yeah, or radians. So degrees you put it in. Okay. So that's one question. We're going to look at another question from the same exercise. This is question number 3, and it says, question number 3, I just read it to you. It says there is a line L1 which passes through the point. So there is a line L1 which passes through the point minus 6, 3 and is parallel to 4 minus 3. That's my L1. And then they say there is another line L2. Another line L2 which has a direction vector, 5i plus 4j, and cuts the y-axis at 0, 8. Find the acute angle between the two lines. So the question is to find out the angle between these two lines, and for that I need the two direction vectors, b1 vector and b2 vector. So when I look at my question, L1 says L1 is the line which passes through the point, and I don't want the point. What I need is just the b vector. It's parallel to 4 minus 3, so that becomes my b1 vector. b1 vector is 4 minus 3, and L2 has a direction vector which is your b vector. So b2 vector is 5, 4. And we are looking for the angle between the two vectors. So cos theta is equal, that's the formula, cos theta is equal to absolute value of b1 dot b2. So absolute value of 4 minus 3 dot 5, 4 divided by modulus of b1, root of 4 square plus 3 square into root of 5 square plus 4 square. So I try to simplify this. To find the dot product, I multiply the I coefficients. So 4 into 5 is 20 plus minus 3 into 4 is minus 12. Absolute value, but I know this is already positive anyway, divided by root of 4 square plus 3 square, root of 25 into root of 25 plus 16, 41. So I get it as 8 by 5 root 41. And so my theta will be cos inverse of 8 by 5 root 41 Good. Put it into the calculator and write your answer. So that's the acute angle between the two vectors, two lines. Another question. This is question number 4. Question number 4 from the same exercise. And here what they say is, find the angle between the two lines. This is question number 4. It says L1 is R1 vector is equal to 8, 9, 10. So what's the difference you see here? This line is in this space in 3D. So this is minus 16, 7, and L2 is the second line is R2 vector is equal to 15, 29, 5 plus t times 3, 8, negative 5. So these are the two lines given to you, and the question here is to find the angle between L1 and L2. So I know to find the angle between the two lines, I find the angle between the two lines, I need B1 and B2. So I'm going to pick up B1 and B2 from here. So B1 vectors, this is going to be my B1 vector and this is going to be my B2 vector. So cos theta is equal to B1 dot B2 divided by modulus of B1 into modulus of B2. So B1, of course, absolute value sign. So B1 dot B2 multiply I coefficients. 3 3s are 9 plus 16 into 8. 128 minus 128 and then minus 35 absolute value sign divided by root of 3 squared plus 16 squared plus 7 squared into root of 3 squared plus 8 squared plus 5 squared. And that's going to be negative in the numerator, so that will be 128, 35, 163 minus 9, so 154, negative 154 divided by, you put into the calculator, get the answer, and whatever answer, of course, absolute value sign, which makes it 154, so theta will be cos inverse of whatever answer you have here, that gives you the angle. Okay, so we have another third sub question here. They have given you the second sub question there. So what they say is there is another line B2 here, B3 here, L3 here, and L3 has a direction vector. I'm going to call it as B3. B3 vector is 0, minus 3x. The question says find x if L1 and L3 are perpendicular. A third line L3 is perpendicular to L1 and has this direction vector, find the value of x. So L1 and L3 are perpendicular. So those two are perpendicular, L1 and L3. And if they are perpendicular, their direction vectors are also perpendicular. And if two vectors are perpendicular, their dot product has to be equal to 0. So B1 dot B3 is 0. So we take the dot product, so I'll get 3 into 0 is 0, plus 48, 3 into 0 is 0, minus 16 into minus 3, and then 7 into 7x is equal to 0. So 7x is equal to minus 48, so x is equal to minus 48.